So this question is a very basic level just for the warm up. The difficulty of questions will increase as we go from question number 1 to 3 to 4 to 5 to 6, so on. So mass is equal to 0.1 kg. I'm just writing V is equal to 30 meter per second. So P is equal to mass into velocity. This is formula of momentum. If we substitute the values, we will get P is equal to 0.1 into 30 meter per second. That will give us 3 kg meter second power minus 1. A bullet of mass 0.2 kg is fired from a gun with a velocity of 4,400 meters per second. What is the momentum of bullet? So very quickly I will solve it here. P is equal to mass into velocity, and P is equal to 0.02 into 400, and this should give us how much? It should give us 8 kg meter second power minus 1. Now, our question number 3 is a car with a mass of 1500 kg is initially at rest. So two things in the beginning of the question only we can note. The first thing is mass of the car is 1500 kg and initial velocity of the car is 0 because it's at rest. Now let's read the question further. It accelerates at 2 meter per second. So acceleration of the car is 2 meter second power minus 2. And time is given to us for 10 seconds. So t is equal to 10 seconds. What is the final momentum of the car? So if we can find the final velocity, which is v, then by multiplying the mass with the final velocity we will get final momentum, right? So the first task is let's find the final velocity of the car, and we can use the equation of motion. So the first equation is V is equal to U plus AT. And what is U here? U is 0. A is given to us, that is 2, and T is 10. So V is equal to 10 meter second power minus 1. Right? Now to find the PF, you know what we have to do. Multiply the mass of the car, which is 1500 kg, with the velocity of the car, which is 10. So here we will get 15,000 kg meter second power minus 1. Now our question number 4 is a 500 gram cart is rolling to the right. So imagine this is a cart of 500 gram. So be careful, it's not kg, it's gram. And it's moving towards the right and with a velocity of 2 meter per second. So the velocity is given to us 2 meter per second. If it collides with a stationary cart of 300 gram. So imagine I have here a 300 gram cart which is at rest. So the velocity of 300 gram cart is, let's say, u is equal to 0. And just for notation you can write this one as m1 and this one as m2, right? And they stick together after the collision. What is their final velocity? So now this question asks what is their final velocity if they stick together, something like this, and then they move together. Okay, you may have seen this in malls. One cart collides with the another cart. Sometimes they both stick together and start moving forward. So to find their final velocity, we can use the formula of law of conservation of momentum. So what is law of conservation of momentum? We know m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But as we know, finally they both stick together. It means the velocity of the two cart will be same. It means v1 is equal to v2. So we can write the same formula something like this: m1 u1 plus m2 u2 is equal to m1 plus m2, because this v1 and v2 they both are same, so I can give it velocity like, let's say, v final. So vf at the end I'm multiplying with m1 plus m2. Let's substitute the values and find the value of vf. So m1 is, already we know, is 500 grams, so we need to convert it into kg. So it's 0.5 kg, and this one is 0.3 kg. So 0.5 into 2 and plus 0.3 into 0. Why I am taking 0? Because this cart m2 is at rest. I don't have space, so I will write the next step here below the above step. So when the two cards they combine, we can write 0.5 plus 0.3. What I'm doing, do not get confused, I'm using this formula. So m1 plus m2, m1 is 0.5, m2 is 0.3. So I have added, and we have to find vf, so I'm writing vf as it is. So if you will simplify it, you will find 0.5 multiplied by 2 will give you 1, and 0.3 into 0 will give you 0. So 1 plus 0 is equal to 0.5 plus 0.3, that gives us 0.8 into vf. So if we divide 1 by 0.8, because this one will come towards the right side, we will get 1 divided by 0.8. So vf is equal to 1 point, how much it would be, wait, 1 is 8, then becomes 8 2 1.25 meter second power minus 1. So this is the final velocity of the object when they both are in the combined state. Now question number 5. Question number 5 is two objects with masses of 5 kg and 3 kg move in opposite direction. So imagine this is a mass of 5 kg moving towards the right, and this one is a mass of 3 kg moving towards the left. So these are the velocities. Because they are in opposite direction, so I have written like this. Now the question reads further, the velocity of the 5 kg object is 4 meter per second to the right, so it's a 4 meter second power minus 1, and the velocity of the 3 kg object is 6 meter per second to the left. It means this is 6 meter second power minus 1 towards the left side. What is their total momentum? So to find the total momentum of both the objects, total momentum, we can write total momentum is equal to 5 into 4. It means the momentum of first mass, right? So let's say momentum of P1, and I have to add the momentum of P2 in this. We will get the total momentum. But the important thing is the velocity of mass m2, or you can say the 3 kg mass, is opposite to the velocity of 5 kg mass. In that case, if you are taking this 4 meter per second positive, then because 6 meter per second is opposite, then we have to take this one as negative. So what we need to do here, we need to write 3 into minus 6 meters per second. And now if you will solve it, you will get 5 into 4 is equal to 20, and plus 3 into 6 is 18, and 18 there is a minus sign, so we will write minus 18. So we can write here 20 minus 18 is equal to 2 kg meter second power minus 1. That is the total momentum of the objects combined. Now question number 6 is a rocket of mass 100 kg is initially at rest. So again, we have a question. I think we had solved a question very much like this, but let's see what would be the answer for this case. So mass is equal to 100 kg, not my bad, 1000 kg, and initial velocity of the rocket is at rest. The rocket engine exerts a force of 5000 Newton. So force is equal to 5000 Newton for 10 seconds. Time is 10 seconds. Calculate the final velocity. It means we have to find Vf. I'm putting it a question mark here. So to find the final velocity, what we can do is we can use the formula of force. So you know from Newton's second law, force is equal to mass into acceleration, or force is equal to mass into change in velocity, which is v minus u divided by t, right? So actually this v minus u by t is the formula of acceleration. You already know that. So force is how much? 5000 Newton, and mass is how much? 1000 kg. Final velocity we need to find, so I will leave it as it is v. Initial velocity is 0, and time is given to us how much? 10 seconds. So this 0 will cancel this one, and what we are getting here, if we bring the 100 towards the left side, we will get 5000 divided by 100, which is equal to v. So now if we will simplify, we will get v is equal to 50 meter per second. I'm writing here v this side. So the final velocity of the rocket after 10 seconds would be 50 meters per second. Now the question number 8. Two ice skaters of equal mass, each with a velocity of 60 kg, skate towards each other. So the mass of both the ice skaters is 60 kg each. 60 kg each. And they are moving towards each other, something like this. One skater has a velocity of 4 meter per second. It means the velocity of one, I can take, let's say v1 is equal to 4 meter per second, and the other has a velocity of 3 meter per second. So if I have taken the velocity of this one as a 4 meter per second, I need to take this one as 3 meter per second. But again, be careful, because they both are moving in opposite direction, right? So you can take one velocity negative compared to the another one. But here one skater has a velocity of 4 meter per second to the left. So if I make some correction here, because I just read half of the question and I wrote the value. So guys, the skater which is moving towards the left is having a velocity of 4 meter per second. So I will just wipe it and write it again. So this one is having 4 meter per second, and this one which is towards the left side, is having a velocity of 3 meter per second. Now it's perfect. What is the total momentum of the system? Now these two are the system, correct? So to find the total momentum of the system, what you need to do, you have to add the momentum of system, which is m1 v1 plus m2 v2, correct? Since the masses are common, you can directly do it. 60 into 1 is the one which is going towards the right, is having 3 meters per second of speed, and the another one is having a mass of 60, same again, but the velocity is towards the left side with the speed of 4 meter per second. And since I have taken this 3 meter per second positive, I'm going to take it as negative, which is 4. So here what we will get, 60 into 3 is 180, and minus 60 into 4 is 240. Now, because you can see the total momentum is equal to 180 minus 240, what we will get is total momentum would be negative. It means it would be minus 60 kg meter second power minus 1. It shows that the velocity which we had taken positive, opposite to that will be the combined momentum of this system. It means if the two persons which are here, if they combine together, they will move towards the left side only. Now the question number 8. Question number 8 is very much similar to the question number 7, but again here we will solve it. Two skaters with the masses of 75 kg and 60 kg are initially at rest. So I can say, let's say the skaters are M1 and another one is M2. One is having 75 kg, another one is having 60 kg. Okay, and they both are at rest. It means u1 is equal to 0, u2 is equal to 0. They push off each other, and the 75 kg skater moves to the right with a velocity of 3 meter per second. Okay, so if the diagram is something like this, and after the pushing of each other, if they are 75 kg person is moving towards the right with a speed of 3 meter per second, what is the velocity of 60 kg skater after the push, right? So let's say this is a 60 kg skater. So what is the velocity of this skater? So to find that, what we can do is we can use the law of conservation of momentum. And the law of conservation of momentum says that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Initially, they both are at rest. So u is 0, u1 is 0 and u2 is 0. So we can write here 0 is equal to m1 is how much? M1 is 75 into, it's going towards the right with a speed of 3 meter per second, plus m2 is 60 into v2. V2 we need to find, because they are asking what is the velocity of 60 kg mass. So in that case, if you rearrange or if you bring this towards the left side, you get 75 threes are how much? 3 fives are 15 and 3 sevens are 21 plus 122. And because it's coming towards the left side, you will write minus 60 into V2. So one more step and you will be done with this question. You will get V2 is equal to 225 by 60, and of course the minus. So if we divide this, we will get 6 3s are 18, and how much is left here? 4. So 6 6 36. I'm writing point because there is a 0, so the decimal will shift towards the one step towards the left side. So 3.6. So, and if you will solve it further, you will get more values, but I'm just rounding off here. So kg meter second power, no, my bad. It's a final velocity, not the momentum. So here we will need to write the final velocity should be in meter second power minus 1. So final velocity is 3.6 meter second power minus 1. Now there are two more questions, question number 9 and question number 10. I'm leaving this as a homework for you, and try this, and if you do not get, please comment. I will give you the solution of this question. Right? Keep practicing, and the more you practice, the better you become.